A very good day to Professor Madya Dr. Muhammad Zoinul Abidin bin Abdul Aziz. Let me introduce myself. My name is Malini Mahindran and my group mate Rangita and Wan Irni Aida. This video is done to explain about our Lab 2 session, which is T-Junction power divider. The main objective of this lab session is to design a T-junction power divider, and the second objective is to simulate the scattering parameter of T-junction power divider. Theoretically, a power divider is a 3-port microwave device that is used for power division or power combining. In an ideal power divider, the power entering into port 1 is equally split across the two output ports and vice versa for power combining. There are different types of power divider such as T-junction, resistive, Wilkinson and hybrid coupler. In our case, the T-junction power divider is a simple 3-port network that can be implemented in any kind of transmission medium such as microstrip line, strip line, coplanar, waveguide and etc. In this lab session, we first calculated all the parameters that is involved in designing the T-junction. The given value of characteristic impedance, which is 50 ohm, was used to calculate the output impedance in the ratio of 2:1. The scattering parameter for the 3-port T-junction was also calculated, and we managed to obtain at least 2 of the value to be 0, and later the parameters to design the T-junction power divider using microstrip line was calculated as well. After calculating the width and length for the microstrip line, the T-junction power divider was simulated using CST Studio software to obtain the respective scattering parameters. And finally, the result that was obtained from the simulation was recorded and analyzed. In order to design the T-junction power divider using a microstrip line, a substrate needs to be chosen, so that therefore we chose FR4 substrate, and we chose the height of the substrate to be 1.6 mm, and the relative permittivity of the substrate was 4.7. This video shows the process of simulation of the T-junction power divider using the CST Studio software. We first need to set the range of frequency, which is 1 to 3 GHz, and later we need to create the brick for the substrate FR4 first, and we need to define the dimension, which is the thickness 1.6 mm and also the epsilon value of 4.7. Next, we created the brick for the first junction, which is the input port, with the length of 33.1 mm and the width of 2.9 mm. Later, we also load the material from the library, and we chose the conductor to be copper. Next, we proceed to do the microstrip line for the first output port with the length of 33 meter and a width of 1.33 mm. Last but not least, we also created a block for the second output port with the length of 33 mm and also a width of 1.6 mm. After that, we select the waveguide port and define the port. We need to set the coordinates to free, and we set the Z max to 5. After that, we select the setup solver and select the source types to all port in order to show the graph, the scattering parameters graph. The setup solver takes some time in order to simulate the microstrip line that we designed. Therefore, we obtain our S parameter graph based on the calculation that we did earlier for S11 up to S33 based on the matrix for scattering parameter T-junction power divider. Thank you.